Good afternoon. This is our episode number 5 for audio system, part 1, that discusses the type of connection, interfaces, the basic principles or the general concepts of signals, and how to perform noise reduction for offline recording and audio processing. So basically, our purpose here is to have a quick grasp on the difference between or among different interfaces and the type of connections that should be used when doing audio interfaces. It would greatly enhance the audio processing, audio capture, and routing for your selected system. So to start with, we need to explain the general principles of an unbalanced system that essentially talks about an electrical two-wire interface. And then at the bottom is a three-wire interface wherein the ground, the shield, and the sleeve has been made common. So effectively, they are electrically a two-wire interface. And this represents a standard plus 4 dBu unbalanced audio connection. So the potential difference or the voltage difference from the ground to the hot potential is 1.23 volts. So what are the types of connectors that uses this kind of connection? So we have the PL connector, or sometimes called the jack. We have two types, the standard PL and the mini PL. In our illustration, you will see even adapters. So let's say you have a standard jack and you want to connect it to a mini PL, or standard RCA left and right audio connected to a standard jack, or a mini PL that will be connected to a standard jack. So these are readily available. Next is our RCA connector. So typically used for left and right audio or even video for your home entertainment, video out, audio out system. RCA stands for Radio Corporation of America. So choosing among the type of connectors for unbalanced, I highly recommend that you invest a little bit more by buying high quality connectors for your system. For the balanced connection, in reference to the first illustration, this is a three-wire interface. Notice that pin 1, the ground, is separate from pin 2, in-phase signal, and pin 3, out-of-phase signal. Essentially, pin 2 and 3 have the same signal, only they are out of phase to one another. The same is true with the illustration at the bottom. So an XLR connector utilizes this technique, wherein if you follow the designation for the pin for the ground, pin for the hot, and pin for the cold, the in-phase and the out-of-phase, it will help you in isolating and preventing the noise in the system from being transferred to the next stage of your process. Note that pin number 1 is slightly longer than pin 2 and 3, being the ground, so when you terminate it or connect it to another stage like a mixer, it basically discharges the retained potential in the wires. So let's talk about the theory of signals here for balance and unbalanced. Let's talk about unbalanced first, the yellow box. So it has a two-wire system. So pin 1, the ground, pin 2 is the hot or the in-phase signal. Pin 1 represents a very clean connection. Okay. However, in reality, due to maybe carelessness or poor quality connection, noise can penetrate the system and become part of your audio. So if you look at the illustration, the noise will merge with the information, the audio, and regardless of whatever amplification, band pass filtering, or other process that you might be thinking of, it becomes an inherent part of the output. If we talk of balanced connection, we add the third pin, which is the cold or the out of phase signal. If you carefully look at pin number 2 and pin number 3, they have the same signal, only in reverse or out of phase. And in general signal theory, if two signals are identical and out of phase to one another, if you combine them they would cancel. So we used the same concept earlier in Unbalanced. So now you have the noise in the system. Okay, so pin number 2 on top of the connection here is the in phase, and then pin number 3 at the bottom would be the out of phase. Notice that the audio information is out of phase, however the noise that has penetrated the system is still on the same phase. So a differential amplifier will be able to identify this and allow passage of the signal that perfectly cancels. So you have a clean audio at the output. This is one of the advantages of utilizing balanced connection. I'll be playing a video, an example of how noise cancellation or noise reduction is performed during a recording when noise is present in the system. So please do watch. For the noise reduction, I'm using Cool Edit Pro. Used to be known as Cool Edit Pro, but now it's called Adobe Audition. I'll give you an example on how to clean up a recorded audio. So this is an example. So you may have observed that at the beginning and at the end, there's noise, this one, and this one. Those two noise have the same characteristic. So what I'm going to do, highlight the noise, select noise reduction, and then get the profile or the general characteristic of the noise waveform. So you see here, I can change the value from low noise reduction to high. Now that the noise profile has been done on, I select the whole clip and then perform the same process. If I do the preview, at 80%, you'll notice that you cannot hear the noise anymore. So what I'm going to do, at 80% noise reduction, I'm satisfied, and then I press OK. Notice the noise profile became a straight line, so there's no more noise, and those characteristics of the noise in the whole audio clip will be removed by the system. So you now have a clean audio recording. For more information about digital broadcasting system, please consider buying the book either via electronic or the hardbound version. It's available on Amazon, or you could order through this channel directly. Thank you very much for tuning in, and please do subscribe and click the notification bell for future advisories for succeeding episodes. Please do look forward for the next episode on a simple podcasting setup that you could utilize not just for your social media activities but also for some decent in-house recording capability. Thank you very much.